tend to graph quadratic functions, which will be a parabola. Our objectives here are to find the coordinates of the vertex and the equation of the axis of symmetry. Once we've found that, we'll be able to graph our quadratic function. So first let's talk about the equation for the axis of symmetry. This is a formula that you have to memorize. X equals negative b over 2a, and this is how we're going to find the equation for the axis of symmetry. Notice here where we get the a, where we get the b. We won't need the c here, but that's where the c is, right? So make sure that your quadratic function is written in standard form so that you can identify all those parts. Then we're going to go ahead and just plug it into our formula. So we're going to have negative, then we take our b value. Oh, I didn't give you an equation yet. Let's take an equation here. How about y equals x squared minus 8x plus 12? Okay, so now we have an a value, which is going to be our invisible 1 that's there. We have a b value of negative 8, and we have a c value of 12. Okay, so I'm going to take negative of my negative 8, divide that by 2 of my a, which is my invisible 1 I got from in front of the x squared, and I'm going to go ahead and simplify that to positive 8 over 2, which equals 4. So the equation for my axis of symmetry is x equals 4. So now that I know that, I also know the x coordinate of my vertex, okay? So I have my x equals 4 for my axis of symmetry. That tells me the x coordinate of my vertex, and I just need my y coordinate. So I go back to my function, y equals x squared minus 8x plus 12, and I just put in that value of 4 in for x, and I find what it gives me for y. So y equals 4 squared minus 8 times 4 plus 12. I've got 16 minus 32 plus 12. That's going to combine to give me negative 20. 16 plus negative 20 is going to be negative 4. So I have a y value of negative 4. Those are the coordinates of my vertex. Now I'm ready to start trying to graph. So I'm going to go ahead and graph my vertex. I've got 1, 2, 3, 4, 1, 2, 3, 4. Okay, so there's my vertex. And I know that my axis of symmetry is going to be straight down from there. So I'm expecting a parabola that goes on either side, in mirror image along the axis of symmetry. Now I can also go back to my function here, y equals x squared minus 8x plus 12. And I take note of the fact that my a value here is greater than 0. Therefore, I know my parabola is going to open up. And so that gives me an idea of what to expect for my y values here. Well, my x and my y values for my parabola. So we're going to make a function table. And when we choose x values for our function table here, we want to choose reasonable x values that we know are actually going to be on the graph. Okay, so we look at where our vertex is, and we know the parabola is going up from there. And so we know there's going to be a point where the value is x is 3. We know there's going to be a point where the value of x is 2. There might be one where the value of x is 1. We know there's going to be one where the value of x is 5, 6, 7, etc. So these are the kinds of numbers we want to be trying. So you want to be strategic about the numbers that you choose so you're not wasting your time on numbers that aren't even going to be on the graph. Okay, so then once we pick our x values, we go ahead and put it into the function. So we're going to have 1 squared minus 8 times 1 plus 12, which is going to be 1 plus 12 is 13, minus 8 gives us 5. We'll put our next one in, 2 squared minus 8 times 2 plus 12, that's 4, plus 12 is 16, minus 16 is going to give me 0. We put 3 in, 3 squared minus 8 times 3 plus 12, that's going to give me 9. Minus 24 and plus 12 is going to give me a negative 12, and then my 9 minus 12 is going to give me a negative 3. Then we'll put our 4 in, 4 squared minus 8 times 4 plus 12, that's 16. Minus 32 plus 12 gives me a negative 20. 16 minus 20 gives me a negative 4. We put our 5 in, 5 squared minus 8 times 5 plus 12, that gives me 25. 25 minus 40 leaves me with a negative 15. Negative 15 plus 12 gives me a negative 3. And then I put my 6 in, 6 squared minus 8 times 6 plus 12. That gives me 36 minus 48, which leaves me with a negative 12 plus 12 leaves me with 0. Okay, I want you to notice here the pattern that we're seeing, where we're going down, down, down till we reach the vertex. So here 4, negative 4, this is the coordinates of the vertex, so I already knew how that one was going to come out. And then I'm going back up. That's what you see in a parabola. If your numbers aren't doing that, something has gone wrong and you need to check your numbers, okay? So you should always see that pattern. Let's go ahead and graph these numbers here. I'll take my x values and my y values. I've got x of 1 is y of 5. 1, 2, 3, 4, 5. And I've got x of 2 is at 0. My x of 6 is also going to be at 0. There we go. My x of 3 is going to be at negative 3, so that'll be right there. Then I've got my vertex. X of 5 is at negative 3. X of 6 is at 0. And if you figured out the pattern, if I had done x of 7, it would be back up here. Remember, because we have a mirror image. So then you can go ahead and do your best to connect those. A little hard on the screen here for me. We put arrows at the end because it continues on to infinity, and we have graphed our function. Okay, so just to recap, to graph a quadratic function, first we're going to calculate the axis of symmetry using the formula x equals negative b over 2a. Then you're going to use the x value you found there to find the coordinates of the vertex. You're going to graph the vertex. Then you're going to make a function table using reasonable x values you've determined from looking at where the vertex is on the graph. Then you will graph those points and connect them, and you have your parabola. For your try these, go ahead and do number 4 through 11.